Good afternoon, everyone. Welcome to this webinar organized by the Network for Heating and Cooling with the name of Achieving Net Zero. We have two talks today. As you may know, this network is funded by EPSRC with a view of finding the ways of addressing some great challenges in decarbonizing the whole operation of our society and our industry. And again, the heating and cooling in the summer time is a big consumer of energy. So I hope that you will find that the talks today give you some idea of challenges and some idea of the technical approaches that we may have. So I thank you all for the interest in this area. Our second presentation given jointly by Professor Ugalde from Cardiff and Dr. Khosravi from Exeter, who will be talking about Flex Cool Store. Professor Ugalde works in electrical power systems in Cardiff University. He's a deputy director of Center for Integrated Renewable Energy Generation and Supply. I think his first degree comes from Mexico and Monterrey. That is where he worked before moving to the UK. So his research interests include power system stability and control, grid integration, and control of renewables, as well as many other topics. Dr. Khosravi is an environmental social scientist with a background in climate change and environmental management. So I guess this next talk will be quite multidisciplinary, and please proceed.
Okay, many thanks for the very kind presentation, and also many thanks for inviting me and my colleague from Exeter University to deliver this talk. So as was mentioned, my name is Carlos Ugalde. I'm the principal investigator of Flex Cool Store, which stands for Flexibility from Cooling and Storage. And I'll be talking alongside Dr. Khosravi from the Energy Policy Group of University of Exeter. Now, these will have a slightly different taste because we will be focusing the discussion around cooling, which is arguably a reasonably interesting topic in the UK, and it's becoming more and more relevant with increasing average temperatures and climate change in general. So let's get on with it. And on that note, I guess that the part of my presentation is a simple one because I will be giving a general introduction to the project, whereas Mehri will be discussing some of the preliminary research outputs from the project. So what the project is about. So let me start by discussing the overarching objective of the project. As was mentioned before by our chairman, this is an interdisciplinary project where the idea is to combine the complementary strengths of the research group, in which we're aiming to investigate the potential impacts of growth in UK cooling demand. So that's for starters. And we will examine how this growth can be managed through the flexible operation of the energy system, but considering energy storage. And we will also investigate how the new demand can be served by an increasingly decarbonized electricity system. So that's the link with the electricity system as well. There are a number of aspects that we would like to emphasize through the project. We will put an emphasis on residential, commercial, and civic buildings. And the goal is to define prospective cooling demands and the required cooling infrastructure. Very importantly, and underpinning this, we will make use of public perception towards the adoption of cooling technologies, that is within buildings and communities, but also taking into consideration the consumer participation in flexibility provision. And the way to assess this will be through interviews and public workshops. Importantly for Mehri's group is that the outcomes will be considered alongside pathways and policies that are associated with heat decarbonization, so well alongside the talk earlier from mine. And an analysis carried out using elite interviews with policymakers will be conducted. This is going to be linked to what's coming next. Now, this is clearly an interdisciplinary project, and the approach will enable the project to address the issue of cooling decarbonization from a variety of angles. And that will enable us to develop an even stronger relationship around buildings and decarbonization. So what you can see in the slide right now are the specific objectives of the project as we presented them at the proposal stage. If I focus on the first one, the idea is to conduct detailed technical, socioeconomic, and policy studies. And this will enable us to understand how cooling demand might change over the next few decades. For this, we will consider 4 main points. That is rising global temperature, within a UK context, of course, working from home habits, and this has been potentiated by what has been happening over the last couple of years with the COVID-19 pandemic, and increased well-insulated and retrofitted buildings, and potentially a green recovery leading to higher welfare. With regards to the second point, we will aim to quantify the extent of which supply and cooling will affect peak electricity demand and the implications on network reinforcement. For these, we will get informed decisions from practical projects. Also, analysis as to how impacts of cooling demand will affect distribution and primary electrical substations will be carried out. The final objective is regarding the interactions and synergies between cooling and electricity systems and how this can be supported by electrical and thermal energy storage. Just a few facts and numbers from the project. We recently started, that was towards the end of September 2021. We have the research team in place. So nominally supported by the project, we have 4 researchers and 1 PhD student, but the research teams from the 3 universities are, of course, supporting us. If I discuss the partners very quickly, so we have a strong force from Cardiff in terms of the techno-economic aspects. So we are leading the project. We have University of Bath and the Center for Climate Change and Social Transformations, who are conducting leading social science research into climate change action, and the Energies Policy Group focusing on governance that can constrain and enable sustainable energy systems. So Dr. Khosravi is from the group in Exeter, and you can see the list of academics and researchers in the project. Just touching upon how we pretend to deliver the project and how we are starting to deliver it, I would like to use this diagram because at the right-hand side, the top diagram, we show the 3 research strands and the 3 research teams through a color coding code in which we couple the social science elements with policy and techno-economic aspects. So red for techno-economic, led by Cyrex in Cardiff University, blue for policy led by Exeter, and policy and governance led by Exeter in green, and public perception led by Bath. And as you can see from the project structure in the diagram to the left and spanning towards the right, we are keeping the color coding there so that you can see how the different strands are linked together. And the idea is to start with trying to define cooling demand in the next years leading to 2050, then understand the different technologies that can help us to deliver meeting these demands. And you can think of reversible heat pumps and linked to other type of thermal energy storage based on latent heat, sensible heat. What infrastructure needs to be included or reinforced so that we can deliver these forecasted cooling demands. And then in work package 4, looking at the different interdependencies with the rest of the energy system. And overarching, assessing the policy impact within the UK context. So with that said, I would like to pass the word to Dr. Mehri Khosravi, who is going to really start talking about the outcome so far in the project.
Hello, everyone. Good afternoon. Thank you, Carlos, for introducing the project. As mentioned, this is Mehri from University of Exeter. I'm working on flexibility, cooling, and storage project. As explained by Carlos in his last slide, this project consists of 5 work packages, which start with cooling demand and cooling challenges in the first work package. My presentation provides some literature review based on cooling demand. Looking at cooling demand across the group shows that 20% of total electricity use is total electricity consumption is used for for providing space cooling, and this is going to be increased due to climate change and also the new style of working from home. This graph shows, this is the graph provided by European Environment Agency based on some historical climate data from 1915 to 2020. And based on this graph, heating degree days are increasing and cooling degree days are increasing, which can be a kind of proof that the projection about temperature increasing is already happening. And in the next slide shows that this is happening in the UK as well. That although the current cooling demand in the UK is small, like 3% of total fuel consumption and 10% of electricity used, but it's going to increase due to rising temperature. Looking at the UK climate data shows that we kind of already feeling, these global warming. If we compare the, temperature, the average temperature in the last decade with the current decade, and based on UK climate projection, apart from increasing the average temperature, we will have a kind of heat wave, what UK experienced in 2003 as a normal event for UK summer before 2040. So due to increasing temperature, definitely we will have some more houses that experience overheating problem during the summer. And we have looked at the current cooling demand in the UK, which shows the current cooling demand is dominated by non-domestic buildings, and among these non-domestic building, office sector has the largest cooling demand, like more than half of the energy used is consumed by this sector. And in the next slide, we have looked at the active cooling technology. As you may know, we have two main approach or strategy to deal with cooling demand. One is passive cooling strategy, which can be related to building code, insulation, shading, and that we can reduce the cooling demand. The other way is using active cooling technology and using tools to provide the space cooling. The first graph shows the various different type of active cooling strategy currently used in the UK, and based on the data, single split is the most type of device which is preferred in the UK. Nearly 80% of tools are single split, which is mostly used in offices. And the second graph shows the difference between these type of cooling device which are used in domestic and non-domestic buildings. So definitely nearly most of these cooling devices used in non-domestic buildings. And but apart from these kind of cooling technology, we have some efficient active cooling technology which is used in some countries, like district cooling system, which is more efficient compared to individual device which can be used like single split. District cooling is really common in hot climate like Middle East, and even in cold climate like Nordic countries, and also in Western countries like Germany and France. But looking at the UK current progress on cooling, on district cooling shows we are still in the emerging step compared to Nordic country or elsewhere in Europe. The other reversible heat pump are another type of efficient active cooling technology. The reversible heat pump can be used as a single system to provide heating and cooling at from one device. And they are very popular and dominant type of heat pump in the global market, including in Europe. The first graph shows the percentage of the heat pumps sold in 2018 in the Europe based on different type of heat pump. And as you can see, reversible heat pump are the dominant type. Nearly 48% of the total sale. And the second graph shows the type of heat pump based on per country and the heat pump sale, which shows if you can see, you can see UK has the smallest part of heat pump sale in the UK, and most of heat pumps are hydronic air to water heat pumps. And looking at these are the section the section we talked about was more about non-domestic building, but looking at the UK cooling demand related to domestic buildings. Actually, there's a limited data on cooling demand from domestic building, and also there's limited understanding how domestic building and household respond to extreme heat and cooling demand. But National Grid estimated that uptake of air conditioners as active cooling method will increase from 1 million to 80 million by 2050 to respond to overheating. And if this happens, we will have a kind of non-unsustainable cooling approach like what we can see in this photo if we stay using air conditioner and not moving towards a more sustainable approach like district cooling. And so in the next slide, now the question is to what extent this cooling demand has been considered in the UK energy policy. To respond to this question, we have done a kind of a literature review. First, we adopted a kind of conceptual framework to see what criteria we need to consider while we're doing looking at the literature. The framework avoid sheet improve is a framework that we have chosen to do our review. It started with avoid or reducing cooling demand, which is reducing energy demand is the basic and simplest pillar in any decarbonization program. So we started with this pillar, looking at building code, and then in parallel we need to look at improving the energy efficiency, which can be done through looking at cooling equipment efficiency, F-gas reduction in cooling demand, and the more important thing is we need to look at the shifting from using the unsustainable cooling equipment like air conditioners to more efficient device or system like district cooling. And then the last pillar is shifting to renewable energy rather than using fossil fuel. In terms of avoiding the energy demand, the Committee on Climate Change has made some recommendation on using a passive strategy to reduce the risk of overheating by reviewing the building standards. And the heat and building strategy, which was published by government 6 months ago, considered passive strategy to reduce overheat. But there have been some criticism over the strategy, because in terms of passive cooling strategy, the document has only considered new building and it means the strategy doesn't cover existing building. But as we know, most of UK housing stocks are existing building. In terms of, in the next slide, we have reviewed the improving of energy efficiency of, the policy related to improving the energy efficiency of cooling equipment and F-gas reduction. Energy efficiency in generally regulated by eco-design and eco-labeling regulation, and EU has some regulation for these two aspects which retain in the UK law. In terms of F-gas regulation, again, EU has some regulation which came into force in the UK. Based on this EU regulation, European countries have to reduce nearly 80% of using HFC in the equipment, including cooling equipment. And under the existing F-gas regulation, UK has already reduced 40% of HFC consumption in all equipment, but in reality, most AC devices and heat pumps rely on F-gas as a refrigerant because existing ban doesn't cover AC devices or heat pumps. So again, there are some criticism over the existing bans, and there are hope that more bans will be included in next F-gas regulation revision in the UK. But most important aspect of improving efficiency can be related to using more efficient equipment such as reversible heat pump and also district cooling, which is so common in some countries which are even colder than have a colder climate than UK. These kind of technologies are still absent in UK policy. The other aspect of this framework is about shifting cooling to renewable and thermal storage. Not only literature, reality shows that countries with established expertise of district heating could pave the way for applying the district cooling. We can see this technology in Nordic countries which have established district cooling, and at the same time they have both district system at the same time. In the UK, based on existing policy, based on the clean growth strategy, heat network is projected to provide heat 70% of heat demand in the homes and 24% of heat demand in industrial building. But progress shows that only 2% of building heat demand is provided through heat network. And looking at this low speed, despite of focusing of a heating solution policy, we can say that UK is far behind in shifting cooling to renewable energy or district cooling. So in conclusion, we can say that cooling has been underrepresented in the UK energy policy, despite the risk of overheating in the UK, which has been considered in the climate risk document. And to consider cooling sector in the UK policy, it is important to understand the status of cooling demand, the current cooling demand and future cooling demand, users' behavior, impact of future cooling demand on electricity grid, and how we can combine, some cooling decarbonization policy with heating, with considering social, technical, and institutional factor. These are based on these lack of research. Our interdisciplinary project has been designed and funded by EPSRC to provide some strategic recommendation and contribution of cooling aspect to net zero transition. Thank you.